Okay, 4.3. I've got 4.3a. Don't know if I'll need them. We are going to be doing story problems, so of course they take a little bit longer to go over, but there's only 7 examples. So hopefully we can get through them in the next 12 videos or so. Just kidding. Example 1. So this is applications. So when we're doing applications, we're taking systems of equations and doing story problems. So it makes it a lot easier to come up with equations because you're using systems of equations. So you can have 2 variables and 2 equations, and instead of trying to make it fit into one. So example 1. One number is 2 more than 3 times another. So we have 2 numbers there, one number and another number. The one we know the least about is, I would say, probably another number. We don't know anything about that. We know that one of the numbers, and let's call that x, is 2 more. Oops, why did I put a 3 there? Is 2 more than 3 times another. So there's my first equation. I'm taking my number here, and I'm saying that it's 2 more. So I had to add 2 to this one because it's 2 more than 3 times another. So this one equals 2 more than this one times 3. All right, their sum is 26. So there's my 2 equations. So that's not too bad. So what I think I would probably end up doing is substitution instead of the addition, because substitution, this top equation, is set up as equal to y. So that means when I look at this equation, whenever I see a y, I can put the 3x plus 2 in its place. So x equals 6. My other number, I'm going to take this 6 and I'm going to put it in here. And I know that my other number, y, is going to be 20. And I can check that by saying, is 20 3 times 6 plus 2? If I put it back in my original equation here, yes it is, so therefore I'm good to go. All right, so that was the easy first one. So let's go and look at some other ones. Let's go to example 2, has to do with money. So we've got 850 tickets, and we sold those for $1,100. If adult tickets cost $150 or $150 each, and kids' tickets or children's tickets are $1 each, how many of each kind of ticket were sold? All right, so I've listed stuff down here just like the first step says. Now we're going to assign variables. I am going to leave A as the adult ticket and C as the children. The book says let's make X the adult ticket. Well, then I got to try to remember, does X mean the adult ticket or the kid ticket? So it's kind of a pain. So I'm just going to leave A for adult and C for child. All right, so what do I know? Adult tickets cost $1.50. Children's tickets cost $1. How many of each kind were sold? Knowing that there were 850 tickets sold total. So the adult tickets plus the child tickets equals 850 tickets. Now I have no idea how many adult and how many child tickets were sold. All I know is if I add them up, I get 850. I also know that if I took $1.50 times the number of adult tickets, that would give me how much money I made off the adult tickets. If I took $1 times the number of children's tickets, that would give me how much money I made on the children's tickets. So therefore, the amount of money I made on the adults, the amount of money I made on the children is going to give me $1,100, which is what I have right there. So there are my two equations, this one here and this one here. So let's take this top one and put it below here. And now what I need to do is figure out whether I'm going to use elimination or addition, or if I'm going to use substitution. Well, first of all, let's go ahead and change these decimals to whole numbers here. Oops, I didn't mean to do that. So let's change this 150 to, let's move it over one decimal and make it 15. Make this one 10, and then we'll move this decimal that's here over one more and make that 11,000. So let's do that. We're going to move that one over and make it 10. If I can figure out how to erase. There we go. And we'll make that 10. So we moved it over. We're going to move this one over from here over to here and make that a 15. Okay. And I am also going to clean this up. I'm going to take my parentheses off of here. That just keeps it a little cleaner. Okay. So I didn't really do anything. Take the $sign off. Except move the decimal over and take my parentheses off. All right. So what I need to do is, let's get rid of the C's. So I'm going to need to make this a -10 in order to add those and get rid of them. So if I multiply this whole thing by -10, I'm going to get, and let's just keep it in one level, I'm going to get a -10a. And this is going to be a -10. And this one, this one over here, I'm going to multiply it by -10, so I'm going to add a 0 and a minus. So there we go. Now all I have to do is add 5a, those go away, equals 2,500. So that means a equals, 2,500 divided by 5 equals 500. That's how many adult tickets I sold. Well, I sold 850 total, so 850 minus 500 is, is 350. So that's how many children's tickets. This is how many adult tickets I sold, and there's my answer. So example 3 is very similar to example 2. But instead of tickets, we're putting money in different savings accounts. So we have a total of $10,000 that we're dividing up into two accounts. One account earns 8%. Another account earns 9%. So those are our two accounts. So if the total interest earned from both accounts is $860, so the amount of money I'm going to get back after a year when I add the amount of money invested at 8 and the amount of money invested at 9, when I get my statement back, it's going to say, not only do I have my $10,000 that I initially put in, but I also have an additional $860. How much did I invest in each account? So what I'm interested in is how much money did I put in at 8% and how much money did I put in at 9%. And when I add those two amounts, I have to get 10,000. So I'll call one X and one Y. the amount of money in X. In fact, let's call this one Y and this one X. This is the amount I put in each account. So the amount I put in X, or in 8%, was X. The amount I put in at 9% is X. The amount I put in at 8% is Y. So add those two amounts up, and I get, $10,000. That's how much money I invested. And then I go back to what I had said before. The amount of money I invest times the percentage gives me how much of this was invested at 9%. So 0.09x is the amount of money I invested of my 10,000. 0.08y is the amount of money that I make off the interest at 8% from the amount I put in at y, and that's going to equal $860. So this is the amount I invested times the percent, the amount I invested times the percent, add those together, and I get the amount of interest, $860. These two numbers are the amounts I invested, and they have to add up to $10,000. Okay, again, we've got decimals here, so let's move these decimals from here over to after the 9. So we're going to move them 2 places. So if we move those 2, we have to move these 2, which means add 2 zeros here. And let me get my little eraser here. So this is going to go away, and this is going to go away, and it's just going to be 9x plus 8y equals $860, or $86,000. Okay, so got a couple options here when I do this. I can make this a minus 9x or this a minus 8x. Doesn't really matter. So if I'm going to get rid of my x's, let's say that I want to multiply that top by a negative 9. And that gives me, let's put the equation down here, we'll rewrite it all. Okay? Then we're just going to write that same as. Okay. So when I add these, I get 0. When I add these, I get negative y equals negative 90,000 minus 86,000 gives me negative 4,000. Okay, problem with that is we cannot have a negative $4,000, but this is a negative. So we just change both of those to positive, and my y equals 4,000. Now I go up to the original equation here, wherever that may be. I guess it's right here. And find out, okay, if 4,000 was invested at 8%, how much was invested at 9%? Well, the difference between 10,000 and 4,000, so it would be 6,000 would be invested at 9%. So what does the question ask us? How much was invested in each account? So that's all I needed to know. 4,000 in one account, 6,000 in the other. So that is 4.3a, and next video is 4.3b.